Hello, you guys. Let's talk about similarity and measurement. So in example 1, they gave us that RSTV is similar to WXYZ, and they want us to find VR. So the first thing I did with my red is I marked V to R, and then I found it over here, V to R, so the last letter to the first letter. So then I used my red and I did Z to W, and I marked that. Okay, so they want us to use ratios to set up a proportion to solve it. Okay, and now with my blue, notice how they wanted me to compare XY and ST. So I found XY, the two middle letters, and ST, the two middle letters. So with my blue, I made XY and ST. So this is how we'll set up our proportion. We said XY over ST, so the little shape over the bigger shape, equals, and then I used the red, the WZ, the little shape, over the big shape, VR. And then I plugged in the values, so I said 10 over 14 equals 15 over X. And then they wanted us to use a cross product, so I multiplied across. So X times 10 gave me 10X over here, brought down the equal sign. 14 times 15, I wrote that on the other side, and then you just multiply. 10x equals 210, and then divide both sides by 10, so x equals 21. So the length of the missing side from V to R is 21 inches. Okay, take a look at this checkpoint. Given triangle PQR is similar to triangle VTS, find the distance from T to S. So with my red, I always underline the TS. Notice how those are the last two letters. So I underlined the last two letters, QR. So I went from T to S and made that red. And then I went from Q to R and made that red. So those sides match up. And then the other side, the blue side, I grabbed my blue and I noticed that P to R matches with V to S. So I made those blue so I could set up my proportion. And remember, with the proportion, it's easy to go from the little shape to the big shape, okay? So look at what I did with red. So I did TS, little shape, matches with QR on the bigger shape. And then look at with the blue, VS, little shape, on top. It matches with PR, bigger shape, on the bottom. Then I plugged in the values. So from T to S was the X. From Q to R was the 12, from V to S was the 10, and from P to R was the 15. All right, and then I reduced 10/15 to make that 2/3, and then I did cross products. 12 times 2 would give me 24, 3 times X gives me 3X, and then I divided both sides by 3 to figure out what X was, and I got X equals 8. So I know the distance from T to S has to be 8 inches. Remember, I knew it was inches because look at all the labels, they're inches. Okay, so look at example 2. At a certain time of day, a person who is 6 feet tall casts a 3-foot shadow. So here's a person 6 feet tall, and here's their 3-foot shadow. At the same time, a tree casts an 11-foot shadow. So here's the tree. I don't know the height of the tree, so they called that H, and here's the 11-foot shadow. The triangles formed are similar. Find the height of the tree. So notice what they did, and I used my red, so I made the height of the person matched the height of the tree in red, and the shadow of the person in blue, and the shadow of the tree in blue. So they wanted us to compare the height of the tree over the height of the person has to equal the shadow of the tree over the shadow of the person. So they're going from the big shape to the little shape, which is fine. You can do that. You just have to be consistent, okay? So H over 6, that's the comparing the heights, equals 11 over 3. That's comparing the shadows. All right, and then I used cross products, so 6 times 11 gave me 66, brought down the equal sign, and 3 times H gave me 3H. And then to solve for H, remember, to get rid of the 3, we have to divide both sides by 3, so H equals 22. So the tree has a height of 22 feet. Okay, now I love example 3 because now we're going to use algebra and similar triangles. So here's what we know. We're given that triangle ABC. So from A to B to C, the big triangle, is similar to triangle DEC. So start at D, go to E, go to C, the smaller triangle. So they want us to find the distance from B to E, the X right here. Now, I think it's really hard for people to keep the shapes together. So look over here, and I want you to try to draw this in the margin. I want you to draw the little shape, CED, the little triangle, okay? And then draw the bigger triangle, CBA, right here. So I want you to draw those and label them. So we know from C to E is 30, from E to D is 16. Now, from C to B, this whole distance here, remember, it's 30 and x. Well, in algebra, the way to write 30 and x is to say 30 plus x. And then from B to A is 24. All right, so now that we took the triangles apart, it's easier to match, okay? Let's match this top edge, the 30 and the 30 plus x, with our blue, and then this side edge with our red, the 16 and the 24. Okay, so here's what they did. They compared A to B, so from A to B on the big triangle, matches with DE on the little triangle, and I show you with the red. So from B to C on the big triangle has to match from E to C on the little triangle. So again, they're going from the big shape to the little shape, which is fine. We just have to be consistent. And so now I plugged in the values. So from A to B, I put in 24. From D to E, I put 16 down here. From B to C, I put 30 plus x. And then from E to C, I put in 30. All right, now I would reduce this fraction. See the 24 over 16? Let's divide both by 8 to get 3 over 2. And now we can do the cross products. So 30 times 3, I put here, and then it's 2 times the quantity, 30 plus x. So notice how I wrote that, 2, and then the 30 plus x is in parentheses. So now when I multiply, 30 times 3 is easy, that's 90. But when I do 2 times the quantity, 30 plus x, you have to do the rainbows, the distributive property. So 2 times 30 gave me 60, and then I copied the plus, and then 2 times x gave me 2x. And now it's just a two-step equation, so we got to get rid of the adding 60 first. So let's subtract 60 from both sides of the equation. So that gave us 30 equals 2x. And then to get rid of the 2, we have to divide both sides by 2. So x equals 15. So the length from B to E, that x, is 15 inches.